So we've talked about, well, first of all, how do I graph this? You should know how to graph that without a table of values. Where do I start? 0, 0. That is called the vertex. Now what? One across, one up. Two more points. And then from the vertex, not from these 2 points, from the vertex, 2 across, 4 up. And that is the most basic one. Again, you can write f of x or y equals x squared. If we did a table of values for 2x squared, it would look like this. It would also have its vertex at 0, 0, because if you plug 0 in here, 0 squared times 2 is still 0. However, if you plug 1 in, what's 1 squared? Times 2? So that means instead of going up 1, it would go up 2. How much do you think it's going to go up on this side? 2 as well, right? Because it's symmetrical. Now, without thinking of a table of values, if I went 2 across, normally I go 4 up, right? How much do you think I'm going to go up for 2? 8 up, because it's times 2. And that makes sense, because 2 squared is 4, 4 times 2 is 8. So you see, when we did that one, it was a narrower parabola. Follow the pattern. What about half x squared? Well, again, starts at 0, 0. I go 1 across each way. How much do you think I'm going to go up? Normally, I go 1 up, right? In the basic one. But this is telling me to go half of 1 up. So a half. On the basic parabola, I go 2 across, 4 up. How many do you think I'm going to go up on the half? 2. So you see how we can do that without a table of values. Notice that half makes it wider. So we've done all these. Let's go back. Think of the purple one, the x squared. What do you think negative x squared would be? Yeah. Basically, all the y's become negative. So it starts at 0, 0, because 0 squared is 0 and negative 0 is still 0. 1 squared is 1, and then attach the negative after. So it becomes negative 1. And the other moves symmetrically. Instead of going 2 across, 4 up, I go 2 across, 4 down. So you can see what a negative does. It just flips it over the x-axis. So we should be able to get the last 2 from there. Because negative 2x squared is the same as 2x squared, but flipped. Still not blue. I need a different color. orange. Okay. Oh, what happened? No. Why is it not letting me pick? There, there's. But it moved this. Why did it move that? Sorry, I gotta skip this one. There. That's and purple. There we go. Okay. Now that orange. So this one is going to be orange. So it starts at 0, 0. Normally in the negative, I go 1 across, 1 down, but this time I'm going 1 across times 2 down. Notice the amount that you go up or down changes, not the amount you go across. So I go 2 across, 4 down normally, but this tells me to go 4 times 2 down. So I got to go down all the way here. And that's why it's negative 2x squared. And then finally, I guess we go neon green. Negative a half x squared tells me I'm going down because it's negative. 1 across, half down. 2 across, half of 4 down, or 2 down. And it looks like this. That's y equals negative. So we talked about 4 possible changes or transformations. If there's parentheses and a number inside, that tells me my parabola is going to shift left to right. If there's a number at the end being added or subtracted, that tells me my parabola is going to go up or down. If there's a number in front of the x getting multiplied, that tells me it's going to stretch. It's either going to get narrower or wider, depending on the number. And if there's a negative in front, that tells me it's going to flip upside down. So looking at these, let's just quickly review the properties. So what did I do for negative x squared? I did blue. What's the vertex of negative x squared? 0, 0. What's the domain? Never changes. Always the same. Because it goes to the left forever and to the right forever. Be careful with the range. Lowest to highest.
Negative infinity minus infinity.
Negative infinity is 0 with a bracket around 0. And remember, to get the axis of symmetry and the minimum or maximum, we always go back to the vertex. So what's my axis of symmetry?
0.
X equals 0. You need the x equals, because that's telling you that this x tells you it's a line. Is there a minimum or maximum? Yeah, it's at y equals 0. But is there a minimum value or a maximum value? Look at the parabola. Does it minimize out or does it maximize out? It's a maximum value. And it opens downwards at y equals 0. And I get all that information from the fact that it's negative. And I get the actual maximum value from the y coordinate of the vertex. Never changes. To get these two pieces of information to your vertex. What about 2x squared? What did I have? Red. Vertex?
0.
0, 0. Domain? Negative infinity to positive infinity. Range, remember it's going up this time, it's positive 2x squared. And then axis of symmetry, x equals 0. Maximum or minimum? Minimum, because it opens up. So minimum value opens upwards. And where? Y equals 0. And finally, negative a half squared, I believe I did neon green. Vertex, 0, 0. Domain, negative infinity to positive infinity. What about the range? Same as the first one, because it's negative, I'm going from negative infinity up to and including 0. Axis of symmetry, go back to the vertex and read the x, so x equals 0. For minimum maximum, I go to the y vertex. It's going to be y equals 0, but does it have a maximum or minimum? Maximum, because it opens downwards. Okay. Okay, so just to summarize this one, like we did with the previous ones. If there is a number a, represented by the variable a in front, 4 things can happen. A can be positive, A can be negative, A can be a certain type of number or a different type of number. Okay, so first of all, if A is greater than 0, that's positive, right? So that means it opens upwards. If A is negative, it opens downwards. Now, A, the number. If the number is greater than 1, like 2 or 3 or 4, it gets narrower because it goes up quicker. So that means it gets narrower. It's narrower than the original y equals x squared. But if it's a fraction between 0 and 1, like 1/2, it gets wider because it doesn't go up as quickly. Notice that it doesn't affect the vertex. The vertex is still going to be 0, 0. The only things that affect the vertex is when we start moving it left, right, or up, down. So that means the equation of the axis of symmetry is x is greater than 0. The maximum or minimum value will be y equals 0 for both. If A is bigger than 0, meaning if it's not negative, if it opens up, there is a minimum value. But if it's negative, that means it opens down, it's maximum value. Okay, and we kind of already did this. So how do we graph if there's a number in front without a table of values? Remember, when you graph these quadratic functions, always start with the vertex, right? Well, there's no shifting going on, so the vertex is the same as x squared, it starts here. Normally, I go 1 across, 1 up. But this tells me to go how many up? 1 times 3, or 3 up. Normally, I go 2 across, 4 up, but this tells me to go how many up? 12, 4 times 3. So 4, 8, 12. So we get a pretty narrow one here. Which makes sense, because if A is bigger than 1, it's going to be narrow. So those are all the different changes or transformations of x squared. We talked about 4 of them, okay? So we talked about just x squared. We talked about when we put a number 1 at the end after x squared. We talked about when we put a number inside parentheses with x before squaring. We talked about putting a number in front and multiplying it. Okay. And we call this vertex form. Why? Because it allows us to read the vertex. So this is the equation for vertex form. You should be familiar with this equation. A times x minus h all squared plus k. So A controls the stretch of the parabola, specifically vertical stretch, as well as the direction of opening, whether it opens up or down. H controls the horizontal, and I'm going to call it shift. Moves left or right. Whatever that H is, that tells us that the parabola is going to move left or right from x squared. And if there's a K at the end, that tells us we're going to move up, down, in other words, a vertical shift. So now let's just finish off with a couple of examples of piecing this all together. You should be able to graph the following. Okay, first one. When you tackle these things, you might want to see, okay, what letters A, H, and K are represented, which ones aren't? Is there any value for A? Is there any number in front? So that means it's not flipping and it's not stretching. It's a regular parabola, however, it's shifting. Remember, it's in the form x minus, so that means H is 1. We shift 1 to the right. K is 2. So that means our vertex is going to shift 1 to the right, and it's also going to shift 2 up. So instead of starting at 0, 0, I'm going to start where?
1.
And remember, we said it's a regular parabola. There's no stretching, there's no flipping. So from here, how do I get my next 2 points? 1 across, 1 up. Back to the vertex, 2 across, 4 up. Done. And now that we've got the graph, we can get all these properties. Vertex. 1, 2 is shifted. Notice that H is 1, K is 2, and that's the vertex. Domain. Always the same, no matter if it's opening up or down or stretch or whatever. Always that. The range, you got to be careful because the range will shift. 2 to infinity. And the last 2, go back to your vertex to get these numbers. X equals 1. Y equals 2. And then I just have to fill in whether it's max or min. Minimum value. Because I'm just going to shorthand it here. Min value because it opens. I want you to try the next one. On your own, with a partner, it's up to you. Now that we're hopefully comfortable with this.
Oh, wait, hold on. Oh, here we go. So it would be like what?
So this one, all the letters A, H, and K are represented. What's A? Now be careful with this one because this always has to be in subtraction form. So what's H? It's -3 because we moved to the left 3, right? So remember that. And K is -2. So hopefully you guys start at 0, 0, go 3 left, 2 down, and that's where you get your vertex. We have now taken care of these 2. Does it open up or down? Up, because it's positive, but it's going to stretch. 1 across, 2 up. 2 across, 8 up. 2, 4, 6, 8, and 8. And that's what the graph looks like. Vertex, -3, -2, because it's the value of H, comma K. Domain is everything, always. Range, we got to be a little careful with. The range read. -2 to infinity. Equation of the axis of symmetry. X equals, go to the X vertex, -3. Maximum or minimum, Y equals -2. And then we just have to fill in the rest. Min or max? Min because it opens up. Min goes with up, max goes with down. Okay? Go to it. This one's got everything. This one has everything.
There's negative one plus negative four.
Let's tell us two things, structure the flat. What's H? Careful.
Negative one.
A.
One.
So that means my vertex is HK or negative 1, 1. So I'm here. You're halfway there. It is not a regular parabola and it opens down. Okay. So I'm going to be going, now you got to think 1 across, 1 down, 2 across, 4 down, except this is going to change how much it goes down. So I go 1 across, how much down?
4.
A quarter. 2 across, how much down? 1, because a quarter of 2. And it's a pretty wide one. It's going to look like that. So the domain is everything, as always. The range, what's the range? Negative infinity to 1. Go back to the vertex, axis of symmetry. X equals negative 1 and minimum max. So I'm just going to put the value first. And it's a maximum value because it opens down. And again, just a quick summary. The value of A controls the width. If there's a number in front, as well as the direction of opening, if it's positive or negative. H controls the horizontal shift. K controls the vertical shift. The coordinates will always be H comma K. Always. And therefore, the equation of the axis of symmetry will be X equals whatever the X vertex is, which is H. If A is greater than 0, there is a minimum value. And Y equals whatever the Y coordinate of the vertex is, which is K. But if A is negative, that means there's a maximum value, but Y is still the same. It's equal to K. And that last page is just a big, long explanation of everything that we've done. We don't have to worry about it. That's sort of a big sum of everything that we've already summarized. Okay. So now we've dealt with quadratic functions in vertex form, which is good, but it may not always come in that form. Which means we either got to put it in that, which means we got to put it in that form, which requires some algebra. So that's sort of the next step. Okay.
That's what I'm saying.